The scientific method is an empirical method for acquiring knowledge that has been referred to while doing science since at least the 17th century. Historically, it was developed through the centuries from the ancient and medieval world. The scientific method involves careful observation coupled with rigorous skepticism, because cognitive assumptions can distort the interpretation of the observation. Scientific inquiry includes creating a testable hypothesis through inductive reasoning, testing it through experiments and statistical analysis, and adjusting or discarding the hypothesis based on the results. While the scientific method is often presented as a fixed sequence of steps, it actually represents a set of general principles. Not all steps take place in every scientific inquiry, nor to the same degree, and they are not always in the same order. Numerous discoveries have not followed the textbook model of the scientific method, and chance has played a role, for instance. The 6 steps. The number of steps in the scientific method can vary from one description to another, which mainly happens when data and analysis are separated into separate steps. However, below is a fairly standard list of the 6 steps you'll likely be expected to know for any science class. Step 1. Purpose question. Ask a question. This step involves making observations, formulating a question about what was observed, determining if the question is testable and measurable, and does the question fulfill a logical purpose. Step 2. Research. Conduct background research. Write down your sources so you can cite your references. In the modern era, you might conduct much of your research online. As you read articles and papers online, ensure you scroll to the bottom of the text to check the author's references. Step 3. Hypothesis. Propose a hypothesis. This is a sort of educated guess about what you expect your research to reveal. A hypothesis is a statement used to predict the outcome of an experiment. Usually, a hypothesis is written in terms of cause and effect. Step 4. Experiment. Design an experiment to test your hypothesis. An experiment has an independent and dependent variable. You change or control the independent variable and record the effect it has on the dependent variable. Step 5. Data and analysis. Record observations and analyze the meaning of the data. Often you'll prepare a table or graph of the data. Don't throw out data points you think are bad or that don't support your predictions. Some of the most incredible discoveries in science were made because the data looked wrong. Step 6. Conclusion. Conclude whether to accept or reject your hypothesis. There's no right or wrong outcome to an experiment, so either result is fine. Accepting a hypothesis doesn't necessarily mean it's correct. Communicate your results. You can compile your results into a lab report or formally submit them as a paper. Whether you accept or reject the hypothesis, you likely learned something about the subject and may wish to revise the original hypothesis or form a new one for a future experiment.